Hello, I'm Kevin Burgess. I'm a chair and professor of organic chemistry, and I've been teaching graduates and undergraduates for 3 decades. Today I'd like to tell you about 2 observations I've made that apply to learning bonding and hybridization, one of the first subjects to come up. The first observation is that subject impact factors vary. You've never heard of subject impact factors? Well, I made it up yesterday. I'm kind of surprised you haven't heard about it yet. Students tend to think that all lectures are created equal. They think that if they misunderstand one or miss a lecture, no problem. I can not answer the question on that particular lecture. It's probably worth only a few points anyway. I'll make it up by doing better on the rest of the course. Why wouldn't a student think like that? I've never heard of a prof coming into a lecture and saying, well, the material I'm going to teach you today is 10 times less important than that which I taught you last week. But the truth is, lectures are not equally important. No way. The first 7 to 10 lectures in introductory organic chemistry have an outsized importance. If you plot the number of points gained, potentially over the whole course, from these 7 to 10 lectures, it's consistently very high, and because the concepts in those lectures keep coming up over and over again. It's impossible for a student not to understand these concepts and do well, but after lectures become less and less important to the rest of the course. Oh sure, there are some that are more important than others, but probably none that are as important as those first 7 to 10 lectures. Learning less and less about more and more. I made that up yesterday too. As the course goes on, you'll learn more and more, but it's less and less important. Bonding and hybridization then has to be learned at the beginning. Students who do not understand bonding and hybridization cannot really do well in the class. This led me to Burgessify a little equation. My equation defines study impact factor. A study impact factor equals the points that can be earned overall times the attention paid. Study impact factors are not equal for each lecture. They tend to decline as sophomore organic chemistry progresses. Estimating a study impact factor is not easy for people who've never taken the course before. So you have to trust me. The first 7 to 10 lectures have particularly high factors. Study impact factors are also important in another way. Observation number 2. Study impact factors are directly proportional to attention paid, not to the time studying. Many people think that the rate at which they learn is proportional to intelligence and the amount of time they spend studying. This isn't true. Let's take one person with a given intelligence. The amount of attention they pay to a subject is vitally important, but they can spend a lot of study time idly looking at a book and actually thinking about something else. This misunderstanding causes a lot of students to use what I call the give me factor. The give me factor says, well, I spent all this time studying this material. I deserve an A. Give it to me so I can be on my way. Professors hate the give me factor. It means that this subject that they studied for a long time and dearly love is not interesting to the students. There's another psychological effect that makes students think that the give me factor applies. And that is, if a student spends a long time staring at a text or notes or the textbook in lectures, they think they understand it. They spend all this time on this. And maybe they have spent a lot of time, but what they're learning is what the notes and the textbook look like. They can't really apply the material. And that's why they say, well, I've spent this time, I understand it, give me the grade. The way to learn is to force the brain to apply the material. And in doing so, students test how well they understand. And to do this, they need problems. They need the problems more than they need the text. And that's why I wrote this book. It's not a textbook. I like to call it a workbook with an attitude. It's published electronically on Apple Books and it has embedded videos. This is the first electronic book in a series from Byinquisition Press. Why do we call it byinquisition? Well, inquisition is severe questioning, forcing the brain to focus attention. And in the extreme, forcing the brain to think about organic chemistry when it doesn't want to is painful. These workbooks torture the mind using concepts. They require diagrams. They ask tricky questions. They use multiple choice. They even use complete structured sentences. Torture. And this torture goes on, forcing students to either confess that they don't understand or maybe realize that then they really do. So the idea is the student would fill in answers on their iPad, and when they've reached the end of the book, they go to My Answers Online, compare, and any of their answers they think are wrong, they would delete in the electronic version. And then the trick is to give the brain time to forget, to give the brain time to flush out the short-term memory that will go anyway. In a day or two, return to that chapter on the tablet and then see what problems they missed, try to solve them again without looking at the notes or any other text first. It forces the brain to try to remember. This in psychology is called active recall. But if a student cheats and they look at My Answers Online, the learning becomes ineffective and the torture must begin again. Thank you very much for listening. Bye-bye.